Thanks everybody for joining live, and if you're watching this on the recording, thanks for watching that. I'm going to be talking about data productivity for data teams today, and low-code, no-code has a huge part to play in that, of course. I'm going to introduce a top 5 features to look out for, especially when you're looking at a low-code, no-code tool, and when you're evaluating a tool like that to obtain productivity in the data domain. Quick intro about myself. I started my career doing software development, a lot of real-time work in C, coding in fintech and aerospace. I switched over to being a data specialist about 25 years ago now, and I've done a variety of hands-on data roles since then. And that means I've got familiarity with both of those domains. When I switched over, I did so really because I thought the data domain was interesting. Couldn't have imagined then how different those two things are. I'm representing Matillion today, who are platinum sponsors of this event. But in my role as manager of developer relations, I'm really most interested in empathizing with the data engineering experience of building out data platforms. So I'm not just going to list features, I'm not just going to list problems, but during this talk I want to share some of the insights that I've obtained about the data domain in the years that I've been working in it. And I want to make this talk really very widely applicable, not product specific in any way. And also when I do dive into the top 5 features to look out for, it'll be clear why each of those is important in the domain. So there's going to be 3 main sections to the presentation. First of all, what's unique about data productivity? What unique challenges do we face there? The relationship to cloud computing, especially how that presents both an opportunity and a challenge as well, of course. I'm focusing, there'll be a section in the middle, I'm focusing on low-code, no-code here, but I want to answer the question, is there a place for high code or code optional? Spoiler alert, the answer is definitely yes. And then the main part, as promised, I'll be looking at a top 5 features which to look out for to help with productivity in data transformation and integration. So why is data productivity even a problem? Well, the data domain is three things I want to call out. The data domain really is unique. I'm going to be talking about that in further slides. And the cloud has really magnified the unique features and the differences there. And I'm going to be talking about that as well. There's a lot of cloud solutions which are designed for scaling application development, software application development. I'm interested here in those features which are for scaling data solutions in the same way. And also, data productivity is a problem because resourcing is a problem. I've been on the Matillion booth today. I've been talking to a number of people who've just been describing how difficult it is to recruit, and it is particularly bad in data engineering. We've been hearing about people being switched inappropriately into roles they're not familiar with, which doesn't lead to the best kind of solutions. So these are all these are data productivity problems that we need to address. Okay, so what's unique, diving into those then, what's unique about the data domain? Well, first of all, we call them the 3 Ds, distributed data, diverse, and dynamic. When you're working in this domain, you face a constant series of changes from sources. Gone are the days when central IT used to control everything and block everything to some extent as well. It's not controlled centrally. You've got lots of data sources, lots of different data structures, lots of file formats, APIs popping up all the time, and this is one of the things that the cloud has amplified. It's very easy to launch a new SaaS system, get up and running very quickly. It's also with all the cloud productivity features, very easy to build new systems in-house yourself, which means there's more sources to deal with, of course. Also, really, everybody is aware now that data is valuable, so it's becoming a criteria when you're looking at a new SaaS system. One of the things that's top of the list is, can I get my data back out of that? What does it look like? How easy is that? And really, if the answer is no, then it's not a good choice probably. So that means it's becoming easier for people to get at raw data, which again gives more distributed and diverse and dynamic data that the data teams have to deal with. Second point is to do with methodology divergence. Now, this is an interesting one. Software developers and data teams in general don't share the same methodology. They're just not able to for various reasons. I'm going to come back to this point several times in this presentation. Data and state are, to a large extent, not relevant to software developers, and vice versa. The process by which data got to a certain place isn't really relevant to a data processing team. You've got the data there to deal with in front of you. How it got there really doesn't matter, and vice versa. The application teams don't really. That's not their problem to deal with. I believe actually that the rise of semi-structured data actually is as a consequence of this, and in fact it's been driven to some extent by software development because it enables that separation of methodologies. Schema drift, for example, is not a problem for most software applications because they can just send some new data formats out to the data processing teams, and that's the end of the problem for them. Also, one other thing about methodologies, it is pretty much impossible if you're in data warehousing or in a data solutions development to get your users to specify what they want up front. You can never go to a business user and say, how would you like me to transform this column of data to make it compatible with everything else, to make it integrable? And the answer is, well, I don't know, because I haven't seen the data yet, and you won't see the data until the software development has finished. So the consequence of that is that while software application development is usually fairly linear, fairly goes along in a fairly predictable way, in the data domain, it's completely opposite. You kind of have last minute. You need rapid iteration to catch up, make changes that the business needs to see. Completely different methodology. Also, one other point here, that data integration requires data transformation. It's one of the reasons actually for the divergence in methodologies. Just copying data from place to place, co-locating the data, really that's a no-code task. Read replicas and CDC, that kind of thing. That's been solved, but co-locating data doesn't integrate the data. Co-located data is not business ready. In other words, if you copy data from place to place, you retain its original high quality, but it's not very consumable. So in order to get value from data sets, you need to examine them usually in the context of another one, and that means making the data sets compatible, which means you have to transform them. And of course, as I mentioned at the beginning, when there's lots of distribution and diversity and it's all dynamic, it really exacerbates the problem. So scaling data solutions, I want to talk about scaling them in the same way that the Cloud Features has done for scaling software development. It's easy there are lots of Cloud Features to make it easy to build applications, which means there's lots of data sources, lots of diverse data sources, but that doesn't apply to data solutions, like I've been saying. And one of the specific things that I would call out is the inappropriate use of kind of legacy architectures which aren't optimal for cloud setups. So a lot of data processing isn't designed for specifically for cloud data warehouses. I think there's a kind of there's an irony or a kind of a nice circularity here, that if you think of a typical application framework, and most of them are three-tier. You've got data storage, you've got business logic, and then you've got presentation. And it's quite an argument that that architecture arose because it was not cost effective and not scalable to keep that processing within the database layer. So the three-tier model arose kind of in the 1990s as a response to that. Now, with the competition and the innovation that's come out of cloud and cloud data warehouses in particular, completely the reverse is true. It's actually more cost efficient and more scalable to put your compute into the database, into the DBMS, into the cloud data warehouse. So that's basically an ELT architecture as opposed to an ETL. So maintainability, there's a lot of a bit of a confession. I like hand coding. Like I said, I started off as a C developer, but when I'm tackling a problem that way, I find myself often thinking, I know I've solved this problem somewhere before. I've got a code snippet somewhere, and I'll just go find it, copy and paste it, pop it in there. Yeah, that kind of works. Fingers crossed. But really, it's not a valuable use of my time as a human. It's kind of crude, low code, no code approach. That is, it's better to for problems that have been solved like that, reach for something pre-built, and move on to spend your time as a human on something more valuable. So, talking about resourcing for a moment. Yeah, it is difficult to resource data projects. There's not enough data engineers. The teams tend to be fairly small to begin with. If you think about the typical makeup of the different teams of software development versus data engineering, most of the time there's far less data engineers than any other part of the development. And you end up with inappropriate resourcing and inappropriate methodologies and suboptimal outcomes. Or, as I said before, also it's kind of compounded by the fact that any time as a data engineer you present a solution back to the business, you go, there you go, that's the answer to your question. It prompts two more questions. And actually that's a good thing, because if that isn't happening, then you're not delivering the right stuff to the business. It's not relevant to what's going on. But it does mean that there's basically demand always exceeds availability there. If you compare that to software development, well, it's a bit more linear, it's a bit more predictable. The Great Resignation is kind of a cause and a symptom of this. We know that there was, during COVID, there was a lot of reevaluation, and people found, this role I'm in is I'm always quite stressed. Everybody's asking me for more than I can produce. I'm going to move on and do something different, which just compounded the problem, led to a vicious cycle there. Okay, so a little summary slide. I've been trying to explain why it's difficult to manage demand and what's unique about data. The rise of the cloud has exacerbated some of the problems. They aren't really new problems, but they've been around for a long time, but they've just become a lot worse with the cloud. So you've got a lot of data, a lot of demand. That's a problem, but it's a good problem. We like to try and solve those problems. We want to bring value. I believe that with automation and productivity through low code and no code, we can solve that problem. So I mentioned at the beginning, I'm going to talk about code optional and high code and hand coding and that kind of thing. So to be clear, I think there will always be a place for both approaches to some degree. The thing about low code, no code is it's available to everybody to use, which is great. It just kind of uplifts everybody in the organization. But when something has been kind of commoditized and it's available to everybody like that, you have to start looking somewhere else for a differentiator. So you won't hear anybody at this conference today saying, our differentiator is that we've really solved the storage problem. We've found this fantastic way using this new S3 to reduce our costs and have unlimited scale, because everybody's doing that, whether it's AWS or GCS or blob storage, for example. You've got to have look elsewhere for a differentiator. Also, I would say that there is sometimes, I think, a bit of a misconception that AI and ML is a general purpose intelligence. It can do amazing things, and I'm going to be talking about that in a few slides' time, but usually those kind of things are within a fairly narrow context. They're solving a very particular problem, and they're not very flexible. Whereas in contrast, a human can come along, can deal with that very long tail of unusual and rare occurrences that you just can't predict, you can't model for up front. That's where those kind of things is where hand coding can play a part, I think. Okay, so I'm moving on to the second part of this presentation. I promised a top 5. So here's a summary of the things to look out for. I'm going to cover these one by one in the next 5 slides, but here's a little summary first of all. So abstraction means focusing on asking for decisions. You should be a decision maker when you're in a low-code, no-code tool. Context awareness means that the tool is aware of the context in which you're working, and if it's asking you for a decision, it should be giving you appropriate options to make that decision from. Declarative design is an interesting one. This is all about data ops. This is all about getting the computer to do what it's good at, and basically making life easy for yourself. I'm going to be talking a bit about the differences between a declarative design approach versus an imperative design approach when I come to that slide. Deployment and lifecycle, well, that really has to be built in to anything, because that means you can get up and running quickly. You get quick time to first value, which is vital. And also, if the solutions you build are going to be around for the long term, which we really hope they are, then maintenance becomes much the bigger part of that. So anything you can automate there is going to be really help. And finally, enabling reusability. Well, this means something actually quite different, I think, in the data domain than it does in the application domain. I'm going to talk in much more detail about that when I come up to that slide. Okay, number 1, abstraction. This is all about focusing on. You should be asked to be making decisions. It's removal of unnecessary detail. So a low-code, no-code tool interface is simpler than the code, of course. But however, you should not be restricted by that. You should still be able to build up sophisticated logic from smaller parts. I'll give you an example in the data domain. If you have a windowing function, which is a rank or row number plus a filter, that gives you a deduplicator. So you've got something simple, something a bit more sophisticated. Also, yeah, you like I said earlier, you don't have to hand code, but if it's code optional, if it's appropriate, then maybe that's something that you should be allowed to do as well. In summary, look for an interface that's asking you for design decisions, not for detailed technical implementation decisions. You should be finding yourself operating as a tool manager, not as a tool user. A last thing on here, the data fabric that we work in is becoming more and more sophisticated. For example, a data engineer now really has to know all about REST APIs, for example, in order to get hold of data. So look for multiple tools, each of which have a specific focus. It's not going to be one solution that's going to solve all of those things. There should be multiple parts to it, which interplay nicely, so you can deploy multiple of them in an appropriate way. And also, ideally with a common foundation, look and feel, logging, that kind of stuff, just to make it easier to onboard, make it easier to learn and switch between them. Okay, point number 2 is all about context awareness. Now, things are changing fast, as I've been saying. The rate of change is increasing as well, thanks to all these innovations that are coming our way through the cloud. Now, I think that's a great thing. As a consumer, it's just awesome. It's amazing to see all these new innovations that are coming along all the time. But when you have to apply those into your work, It's actually pretty difficult to just make sure you're using the right and the appropriate technique for the latest, greatest thing that's become available. So that's actually a bit of a problem as well, just keeping up. So ideally, a context-aware low-code, no-code tool will kind of silently take advantage of that, silently do that for you. Maybe just say to you, look, there's this new feature I think it's appropriate to use here. I've decided to switch that on. You can veto that if you want, but it's probably appropriate. So you don't really have to know that even that feature existed, and certainly don't need to be an expert in it in order to take advantage of it. Small automations become possible with metadata capture and with context awareness as well. I'm going to use the example, if you're setting up a role-based access control and you are asked to supply an IAM role, then the drop-down list should show you a list of IAM roles. Ideally, you shouldn't even actually have to necessarily know what they are, or certainly not be an expert in them. This is an area for AI and ML, by the way. I think this is one area where it is appropriate. Detecting oddities for you in the data, that kind of algorithm is very good at scanning large amounts of data. For example, detecting personally identifiable information where you might not have expected it. And also for proactive alerting. So, for example, the tool might say to you, I've seen this kind of exact circumstance before, and last time this happened, your job failed. So, preemptive warning, the job might be failing here. Also, semi-structured data, well, as I was saying before, is here to stay. So, really, the tool has got to be able to handle that automatically for you. There should be ease of use features like data parsing and schema guessing and helpers to help you flatten the data and that kind of thing as well. Really needs to be built in. Okay, declarative design. So I'm going to talk about the difference between an imperative design, which is where you say, do this, then do this. If this happens, do that. Very, very prescriptive, versus that kind of 3GL style of development, versus a declarative design mode, which is where you just say, this is what I want to happen. This is how I want it to end up. Just make it happen. I don't really care how you do it. Just don't even tell me. Just make sure it ends up that way. That's more like a 4GL declarative way of building. So I'll give you an example, CDC. That's a really great candidate for a declarative type of design interface. That problem's been solved. Really, we shouldn't be having to mess around with high watermarks by hand in a kind of imperative programming style. Ready for everyone means that it should be easy to understand and to maintain. You can't afford write-only solutions because they're just not maintainable. You don't get long-term value like that. So I think it's important enough to make that a part of an evaluation. So for example, if you're got 2-week trial, week 1, somebody comes in, develops something, gets that working. Week 2, somebody else comes in, maybe cold, and has a look at that and says, oh, well, can I maintain that? Can I understand that? And that way you kind of gain some reassurance that that it's going to be suitable for the long term. One of the unique things about data solutions is statefulness. So it's important that you have assistance through the low-code, no-code tool of working out dependencies, for example, data lineage and ordering and dependencies, that kind of thing. There's a reason, after all, that SQL is so prevalent in the data domain. That's a 4GL, of course, not a 3GL. So recommendation number 4, deployment and lifecycle. Okay, reporting and analytics teams work on data to make it understandable by humans, and that's called transformation and integration. Data scientists work on data to make it consumable by algorithms, and they call that feature engineering. It's pretty much the same task, actually. So there's a lot of frameworks around that, like data ops, ML ops, AI ops, and that all of that, to my mind, shows how much we need frameworks and management and system and order in order to deal with that constant change. So deployment really does need to be a built-in consideration, so you get quick time to value. Difference between development and production is parameterized, for example. It's not hard-coded. Also, I would say technology integration, it's very likely that you'll be using multiple technologies and blending into a wider framework, like using Git for version control, DevOps technologies, or maybe an orchestrator like Apache Airflow, for example. Is vital that that you're able to integrate pretty seamlessly with those technologies, and it's not just an isolated silo. Like I said before, software development and data teams don't share methodologies for the reasons I talked about. It means that the data teams have to be able to make software changes in short release cycles. It's vital, therefore, that you have the ease of change without any sacrifices in the area of governance, because there's no you simply that's non-negotiable. On to the last one, reusability. So the ability to create and reuse functionality. Just because we're using low-code, no-code doesn't mean there's no reason not to stick to good engineering practices. In software engineering, you'd call that dry, don't repeat yourself, largely solved by inheritance. As far as in the data world, what's the equivalent of that? I think the nearest equivalent is logical data layers. So if you have a really complicated report, for example, and somebody else wants a copy of that, not quite the same, it's a lot of work to rebuild that. You need to shift that logic down a layer into the data world. Exactly the same thing applies inside the data warehouse. You can have multiple tiers, staging, ODS, third normal form, data vault, star schema, aggregations, for example. Those layers build upon each other in exactly the same way that inheritance does for software development. So the tool really needs to enable that as building blocks for reusability. So a little summary then. I don't want anybody to leave with a misconception that low-code, no-code means the end of traditional software development and data engineering. It's quite the opposite, in fact. It's a reflection that it's really so important that that we need ways to augment and make the things more widely accessible to everybody. Humans can still be a differentiator. I like to think of low-code, no-code like a robot, a virtual robot that acts on your data. Now, we don't use a robot in a factory because it's the same as a human. We use robots because they are different and they bring complementary skills, exactly the same in the low-code, no-code world. In summary, the low-code, no-code platform needs to make the hard things easy without making easy things hard. A last slide. Matillion, we originated in Manchester, England, dual headquartered in Denver. Everywhere you'll find a cloud provider, you'll find Matillion. Our goal is to help with data productivity with low-code, no-code platform. For more information, if you want to take a look for yourself, or if you want to speak to me after this, I'll be on stand 7:30, opposite side, halfway up. We also have a VIP lounge. You can get the access to that, find out all about that, and a Big Data London pub quiz. So I am not going to do the Q&A because we're really running out of time here. But just thanks everybody who attended in person, and thanks to everybody who's watched the recording.